month ago, I was doing some research to figure out what I wanted to cover in this content. And I have a lot of friends in the industry, established and successful technical artists. So I thought it would be a good idea to get in touch with them and see and ask them one question. And that question is, what is one thing that you truly enjoy about being a technical artist? And the answers I got actually amazed me for 3 reasons. The first one was that everybody was very happy to share their experiences and were genuinely interested in helping people get into the industry. The second reason was that out of all the responses I received, no 2 responses were identical. They were all unique in their own way, and they all reflected their own experiences and the diversity of tech art. And the third reason was, I think, the most interesting of them all. Because even though I asked all of them for one thing that they truly enjoy about tech art, almost every single one of them told me so many things that they enjoy about tech art. So this got me wondering, why I don't see so many people express interest in tech art, and why tech art is not as popular as maybe some of the other roles. And I realized that there's not a lot of information available for tech art. So that's what brings me here today, to talk to you about this exciting discipline and the amazing career you can have as a technical artist. And I'm hoping that by the end of the talk, you'll not only have a much better understanding of tech art, but also feel inspired to pursue a career in this field. So before we start, really quickly, just a little bit about me in case you're wondering who I am, even though Rahul just introduced me. So my name is Chirag. I also go by Tito, and I'm the graphics technical director at Ubisoft Montreal. Basically, I work on all the technical aspects associated with graphic data. And I work very closely with technical artists, graphics programmers, as well as artists, other directors, art director, game director, to make sure that all the visual and technical graphics needs of the project are properly met. So I have a background in computer science engineering, and my first taste of game development was in 2008, when I worked with a college classmate of mine to make a simple space shooter for our final year project in engineering. And after that, I moved to Canada to pursue my master's in computer games technology. And since then, I've been working in the industry. So for the last 8 years or so, I've been working predominantly in graphics and tech art, and really striving to merge the artistic vision with technical capabilities. And I've been very fortunate to work on really well-known IPs like Disney, Jurassic World, and Rainbow Six. And previously, I worked at companies like Gameloft, Massive Damage, which is a small indie studio in Toronto, and Ludia, which is a French-Canadian company in Montreal, which was recently acquired by Jam City. And while I was at Ludia, I was there for almost 10 years. I helped establish and define the roles for technical art for the entire organization. I ran the technical art community there. And we had enterprise support with Unity, so I had the chance to also lead and drive rendering and graphics discussions with Unity, including providing some early and valuable feedback for universal render pipeline, or lightweight render pipeline as it was called back then. So just a really quick overview on what we'll cover today, just so you know what to expect. We'll start off by asking the big burning question: what is technical art? What it means to be a technical artist. And then we'll look at, for a little bit more context, we'll take a look briefly at the background of the evolution of technical art, and more importantly, what it is today, which is what's more relevant for all of you. And then we'll look at the job functions, the functional disciplines of tech art, if you will, to understand what are the different types of responsibilities that fall under tech art. We look at the core competencies. These are the things that you will need to have in order to get into become tech artist, as well as to continue being a successful technical artist. And finally, we'll spend a few minutes just quickly looking at a high-level tech art job plan, but you can follow step by step to see how you can start working towards a career in tech art. So what is technical art? We all are probably aware of all the big disciplines, the more popular disciplines in game dev, like programming, art, design, and so on. Art, of course, is all the visual stuff. And artists are the ones that make everything that you see in the game, the worlds, the characters, UI. Programming, on the other hand, has to do with writing code, implementing systems and features, bringing everything together with behavior and logic. So what does technical art involve then? Technical art is the space between programming and art. And technical artists are the ones that bridge this gap, the technical and the visual. And it's not just one gap and one bridge. In reality, there's a lot of different gaps across various intersections of tech and art. And as a result, there's a lot of bridges that you need to bridge those gaps. So technical art is very broad. It's like a spectrum. There's a lot of things that qualify under the umbrella of tech art. And this discipline has to do with literally any technical aspect of all visual and artistic content. So it could be environments, props, creatures, lighting, shaders, materials, animations, VFX, anything you could possibly think of. And they play a really important role in production, because what they do is they help achieve the artistic goals that are set for the game, while also keeping in mind the technical constraints like performance and memory of the target platform. They do this by streamlining how art is made. They empower artists from how art is authored in DCC, digital content creation softwares like Photoshop or Blender, to how it ends up in the engine, and even after that, how well it performs while the game is running. So as a result, it does vary a lot from studio to studio and project to project, depending on a number of different things like how the team is structured, what kind of tech you're using, and also the size and scope of the project. So depending on the studio, there may be some overlap in responsibilities and some shared responsibilities between technical artists and dedicated artists and dedicated programmers. So next we'll look at the evolution of tech art. In the early days, about 40 years ago in game development, games were very basic, with simple graphics and gameplay. And this was mostly due to hardware limitations at the time. And the teams were significantly smaller, and most of them consisted of the core disciplines with people wearing multiple hats, sharing responsibilities. In the 1900s, with the advent of 3D graphics, came an increased complexity in the way the art was authored and the visuals were implemented. So now artists had to create more complex models, textures, animations, and programmers had to develop rendering techniques to deal with all of this. So this gave rise to game engines, as we know them. And game engines introduced tools for artists, designers, and the need for establishing a pipeline, optimizing assets, and managing all the technical aspects of art creation became very important. So this warranted a specialized role that could bridge the gap between art and tech. And this was when some of the early technical artists emerged informally to handle some of these tasks. And in the late 1900s and early 2000s is when some of the companies started to officially recognize a need for a dedicated role in the industry. And this was a role that would develop tools, scripts, and streamline workflows. And invariably what happened was a lot of the people that ended up becoming the early tech artists were actually artists with considerable amount of experience in the industry that had picked up the technical concepts along the way to keep up with all the advancements that were happening. So historically, technical art wasn't really perceived as an entry-level role because it required such large amount of practical art production experience as well as technical know-how that was specific to this area in order to qualify. Now, fast forward to today, and that mix of technical knowledge and practical experience is still very much important, but things are a little bit different now. Because today, with the way technology is evolving and game engines are evolving, and the complexity with which games are increasing, it also means that the growth, the depth and breadth of technical art responsibilities is also growing, opening up a lot of opportunities in the field. So today, because of this, technical art is one of the most sought after roles in the industry. And studios are often struggling to meet the demand of tech art. And also the other thing with today's world is that it's a lot easier to acquire the fundamental technical knowledge today because of the numerous online resources that we have available, as well as there's now educational institutions that are dedicated to providing that have dedicated programs for tech art. So studios today are more open to hiring technical artists straight out of school and also junior technical artists because of this reason. So next we'll take a look at the job functions within tech art. So technical art encompasses a lot of different functional disciplines across diverse areas of game development. And as a prospective technical artist, it's very important that you understand these job functions because the kind of specialized knowledge and skills that you need will vary from one function to the other. So you may see different versions of this. There's many different ways to slice the pie. This is how I've decided to break them down into 5 categories. So we have pipeline, rendering, profiling, rigging, and tooling. So you could think of these as specializations, but they don't necessarily need to be specializations, which is why I prefer to refer to them as job functions. And we'll take a look at some of these in a little bit more detail. Somebody was asking earlier, so depending on the project, some of this can, and the size of the studio and the project, some of this can vary. So if you're a technical artist, and a bigger studio, you may have the opportunity to specialize in one thing, and you may have a tech artist that's just working on rendering or pipeline. And if you're in a smaller studio, an indie studio, for example, maybe you're just one technical artist and you're touching a little bit of all of these functions. So pipeline, when we say pipeline, basically what we mean is we're talking about the asset creation and integration pipeline. So all the way from digital content creation softwares like Blender and 3ds Max to the game engine and everything in between. So for technical artists working on the pipeline, the main focus is to optimize and streamline the asset creation process. And this is to make sure that the production is as smooth and efficient and error-free as possible. And this is also often behind-the-scenes work in the pipeline because it happens pretty early on in the project, but technical artists can continue to improve upon it and make it better as the project advances. So technical artists will basically design, build, maintain the workflows. They'll establish the guidelines so that the assets are created efficiently and integrated efficiently into the game engine. So some examples of this would be on the digital content creation software side. What version are you going to use? What kind of tools, plugins you may need? What are the export settings? Where is it exported? How is it named? On the game engine side, it could be things like what are the optimal import settings? How are the assets organized in the engine? What is the folder structure? Is there any processing that's required after it enters the engine, like setting up a prefab or configuring asset bundles and things like that? And there's some elements in between too, which are basically to do with like source files, how are source files managed and organized, working with version control, working with asset management databases. So in order to be able to work on pipeline, there's a few things that you need to know. Obviously, you need to have familiarity with the DCC software and their tools. You need to have good knowledge of version control, and also have some familiarity with the asset workflow for game engines. Second category is rendering. And rendering basically has to do with all the real-time aspects of graphics and the techniques that are used to author them. So the main focus for technical artists working on rendering is to work closely with artists and programmers to make sure that they achieve the visual targets that are set for the game, while also respecting technical constraints like performance and memory for the target platform. So they basically develop shaders, they optimize draw calls, they manage post-processes, they help create special effects that may involve destruction or simulations. So some examples of this would be working with procedural aspects, let's say for creating a dynamic weather system or a day-night cycle. It can also be high-level graphics programming, as we spoke about earlier. So this is on top of using the custom APIs and tools on top of the engine, not at a graphics API level. And there's other things as well, like authoring shaders to define how materials look for various types of materials in the game: metal, glass, wood, more complex ones too, like skin and fur and hair. And they also, another example would be like setting up matching data, setting up culling systems, setting up LODs or level of details. So technical artists that work on rendering obviously need to have a good understanding of the graphics pipeline. You need to be familiar with rendering concepts and shading techniques, and a little bit of math knowledge is also important, linear algebra and trigonometry. Next category we have is profiling. So profiling has to do with collecting and analyzing key metrics in runtime. These are things like performance and memory to evaluate and see how well the game is performing. It's a very integral step in optimization, because in order to optimize something, you need to first find potential areas to optimize before you determine what is the best strategy to optimize. And there's many different things that can be profiled. The main focus for technical artists obviously is the visual elements in the game. So profiling for performance and memory of all the visual aspects. And there's a lot of tools for this as well. Most game engines will come with their own suite of profilers, performance and memory profilers, frame debuggers. There's also third-party profiling tools that may be platform or hardware specific. So some examples of profiling would be, let's say, looking at the frame debugger to see what are the draw calls, to see if you could potentially batch some of them together, optimize for the CPU. Looking at overdraw, maybe you want to reduce overdraw and improve the performance on the GPU. Also, using third-party profilers, let's say if you're on iOS, looking at Xcode profiler, and you can use that to look at GPU utilization. You can use it to see how much time is being spent between geometry processing and pixel processing. Memory profiler is another tool as well. You can take a snapshot of the game at any given point in time, look at what are the assets that are allocated in memory at the time. You can look at textures, meshes, atlases, and so on. So for profiling, obviously you need to have very good analytical skills and familiar with a lot of the profiling and diagnostic tools. Also understand a little bit of the rendering pipeline, because if you want to profile for the GPU, you need to know how all of that works. And knowing how memory allocation works is also very important. Then we have rigging. Rigging has to do with creating a digital skeleton or a rig for 3D characters or any objects that need to be animated. And these basically it provides like structures and controls for animators to be able to pose and animate these meshes. And And these meshes could be, they could be characters, they could be creatures, vehicles, weapons, anything that has some sort of articulated movement. So the main focus for technical artists working on this to make sure that the objects are visually and technically ready for animation. And they will typically design and implement the skeletons and the bones and the joints and make sure that the control systems are set up for the animators to be able to pose and manipulate the objects. They also do skinning and weight painting, which is basically associating the mesh to the skeleton and being able to adjust the influence that the bone has on nearby vertices. Some examples of this could be physically based secondary motion, so hair and cloth that you want to move based on the character's movement so that it moves naturally and organically. Another example would be creating facial systems so that the animators can then animate detailed expressions or do lip syncing if needed. So for rigging, you need to have a good understanding of digital content creation software, especially the rigging toolset. Have some amount of understanding on anatomy, kinematics, and be familiar with the animation pipeline. The last category of job functions we have is tooling. So tooling basically has to do with making everybody's life easier by automating all the repetitive and complex tasks, by simplifying time-consuming processes, resulting in overall improved production process, efficient production process. So the main focus for technical artists working on tooling is to create, maintain, and improve tools and scripts for artists, animators, and anybody else on the team. They typically will use languages like C#, Python, maybe MaxScript, depending on where the tool is functioning. And these can help with various aspects, including other job functions of tech art as well. So maybe you have a tool that is for validation or asset management for pipeline. Maybe it's a batching tool. Maybe it's a procedural environment generation tool for rendering. In the case of profiling, maybe it is a diagnostic tool of some sort, a reporting tool that reports all the numbers. And in the case of rigging, it would be an animation retargeting tool. So for tooling, you need to have some amount of programming fundamentals, understand that, and also understand the game engine well, because if you want to create tools in the game engine, you need to know how to extend the game engine. Good knowledge of MaxScript or Python or the DCC scripting languages. And also have an understanding of the end user and what their needs are, because you want to cater the tool specific to the needs that they may have. So next we'll take a look at the core competencies that we spoke about briefly earlier. So these are the competencies that I feel you would need in order to get into tech art and to be a successful technical artist. I've kept it fairly straightforward and split it up into 4 categories. So we have the artistic competency, technical competency, analytical competency, and collaborative competency. Now this is my own classification, but I feel using this as a reference can help you see how your skills are distributed across these competencies, and then it can help determine what areas you may be lacking in, for example, if you want to get into that. So we'll take a look at each of these categories a little bit more just to understand some examples. But just remember that it's not an exhaustive list. Not everything that's mentioned you absolutely have to know. Just to give you a general idea of what would fall under each of these competencies. So the first one is artistic competency. This obviously has to do with your artistic sensibilities, having an artistic sensibility and the artistic aspects of tech art. So here we have things like art fundamentals, 2D and 3D art authoring, lighting and rendering, and animation and VFX. So art fundamentals has to do with things like color theory, visual composition, shadow and lighting, anatomy, and so on. Practical knowledge of 2D and 3D art creation process is really important too, because this allows you to understand the asset workflows, how artists work, and the pain points. So this is also understanding some of the terminologies with DCCs and how artists work, so knowing vertices, texture, channels, UVs, things like that, and also the processes like modeling, texturing, animation. Lighting principles refers to how light behaves. So it's good to understand how light behaves. It helps you make artistic decisions to enhance the visuals. So these are things like direct lighting, indirect lighting, diffuse and specular lighting, what is baked lighting, what's real-time lighting. And being aware of rendering styles like toon shading or pixel art or PBR, physically based rendering, is very useful. Animation has to do with things like timing and motion, anticipation, follow-through, easing, and of course having a visual understanding of special effects like motion design, particle systems, and post-processing like blue or depth of field is also going to be very valuable. Next, we have the technical competency. So this competency obviously has to do with the technical aspects that allow technical artists to develop tools, create shaders, and solve a variety of technical problems. In this, I have some examples: game engine expertise, scripting and programming, shader authoring, and math, mostly linear algebra and trigonometry. So game engine expertise refers to having a solid understanding of the game engine, especially with regards to things like the scripting environment, the render pipeline, and maybe asset management. Scripting and programming, of course, scripts are used like Python and MaxScript we're talking about earlier are used a lot for tools, especially on the DCC side. But also having an understanding of compiled object-oriented programming languages like C++ or C# is very useful when it comes to deeper customization of the game engine or high-level graphics programming. Shader authoring. Shaders, as some of you may know, are basically specialized programs that run on the GPU. They allow you to define the look and feel of everything that's rendered. So you can use node-based editors to author them. You can write them in HLSL or JLSL shading languages. So having knowledge of those languages and understanding the graphics pipeline, understanding the parallel nature of GPUs is going to be very useful when it comes to this. And finally, we have math. Math is used quite a bit when it comes to rendering. So things like having good skills in matrix manipulations, translation, scaling, rotation, vector operations like dot product, cross product. Those are used a lot, especially to manipulate 3D objects, for calculating lighting, among other things. And trigonometry is used for circular motion, it's used for procedural animations, oscillations, and things like that. So then we have the analytical competency. So this has to do with your ability to make data-informed decisions, to troubleshoot issues, and to find efficient solutions that enhance both the artistic and the technical aspects of technical art. So some examples over here: critical thinking, profiling and optimization, attention to detail, and establishing ends. So critical thinking obviously is very important as a technical artist. It's your ability to take a complex problem, break it down, simplify it into more manageable components, analyze the root causes, and then try and figure out what's the best way to tackle them. Having a solution-oriented mindset, so being proactive in anticipating the issues that are coming in, and also exploring multiple solutions, constantly refining to make sure that you're in line with both the artistic and the technical goals that are set. Profiling, of course, knowledge of the profiling tools, as we spoke about before, will really help you find bottlenecks in performance and memory and high memory allocations, for example. And understanding, knowing optimization strategies and techniques will help you resolve those bottlenecks and reduce memory. Attention to detail, very, very important as technical artists, because you need to be able to make sure things are visually consistent, things are properly validated, um, so that all the requirements are properly met. And oftentimes, as technical artists, finding this and catching it early is very useful because you don't want it to become big production problems later. And establishing guidelines, this basically means once you've collected all the information, knowing how to evaluate it and translate it into meaningful guidelines and budgets that the artists can use and follow. And this could be things for things like triangle count, texture sizes, shader complexity. And the last competency that we have is the collaborative competency. So this has to do with your ability to collaborate with others, interdisciplinary teams, how you communicate with them, how you work with them. Under this, I have communication, documentation, training and support, and adaptability. So communication is obviously extremely important. You're a bridge between two parts. So being able to speak two languages effectively, speaking to the artists, understanding that, speaking to the programmers, being able to communicate technical, complex concepts in simple terms. And it's not just oral communication, documentation, it's written communication as well. Because you may want to write some technical documentation to make sure that people understand how the shader works or the custom tools work. And also for guidelines for the artists. Training and support, it's pretty common for technical artists to be able to train and support other artists. You may have custom tech, custom tools that you want to train them, help them understand how to use them. And of course, providing regular support is very important for technical artists because things go wrong, something is not working as expected, and you need to be able to be there and help them understand that. The last category is adaptability, being flexible, being adaptable. We all know that game development is very challenging. Things change all the time, priorities are changing all the time, artistic direction might change, technical constraints might change. So being able to keep up with all of those things, but also keep up with industry trends and techniques so that you're able to pick up on what's happening and how to solve certain problems that you may have in production. So the last part that I have here is the technical artist job plan. It's basically just a high-level plan, not catered to any specific situation or particular individual, but just a general plan. And the first step here is to evaluate your current skills. It doesn't matter if you're a student, you're a professional in the industry, you're a professional outside the industry. Look at what skills you currently have and see how you position based on the core competencies that we talked about. Because maybe you already have some knowledge and develop some skills based on your educational background or based on your past experiences. And depending on what they are, this can help determine the kind of responsibilities within tech art that you might be a good fit for you to transition into. And since tech art is so diverse, there's many entry points into tech art. Determining the ideal path. So next, basically figure out what's the best path for you to get into tech art based on your current skills that you evaluated and based on your current position. So if you're a student, you have many options. You can apply directly as a technical artist. You can apply if you want to get your foot in the door. You can apply into any adjacent roles and then transition into tech art later as well. And if you're already a professional in the industry, then try to find the job functions that make the most sense for you to transition into. So what I mean by that is if you're an artist, you already understand the art authoring process, you already understand some of the workflows, then maybe pipeline is a good place for you to start. If you're a programmer, you already have some coding skills, maybe writing some tools and trying to transition that way is a good idea. If you're an animator, maybe rigging is a good option. And if you're somebody who's a professional but outside of the industry, then you have an additional step. Because maybe you have some of the skills, but you need to understand the specific software or the tech that is used in game development and be familiar with those. The next step, of course, is to continue working on your core competencies, identify areas that you may be lacking in, and continue working on them. And ideally work on them with project-based learning, and not just watch a YouTube video or read a book. Because it's not enough as a technical artist to just have the theoretical knowledge. You need to be able to understand those things and apply that knowledge in an actual practical setting. And that's really important. And that actually brings us to the next point, because next step would be to build a portfolio. So if you're actually doing project-based learning, that sets you up well, because while you're working on these things, you can use some of those to build a portfolio. And the portfolio will allow you to showcase your skills to potential employers. And it will also allow you to demonstrate the knowledge and skills you have through the portfolio. So if somebody looks at your portfolio, they should be able to understand what you're capable of doing. And in some cases, it may be also useful to add some comments and explain certain rendering techniques or whatever you might have used, or thought processes that you might have gone through to get what you ended up doing. The last step here, of course, is to engage in communities, participate in initiatives, participate in game jams, participate in conferences like this, and continue to meet professionals in the industry, because this will give you an opportunity for people to, first of all, know who you are, and for you to showcase your portfolio, showcase your skills, and significantly improve your chances of actually landing a job. So that's pretty much it. I'm just going to do a really quick summary. Technical art, as we said, it's the space between art and programming. Technical artists are the ones that bridge this gap. It's a spectrum. So there's a lot of different things. It involves all technical aspects of various artistic content, and it can vary quite a bit from studio to studio. Historically, technical art wasn't really an entry-level friendly role because of the large amount of art production experience and technical knowledge that you needed. But today, with art and tech growing more complex, the studios are much more open to hiring for entry-level roles, and technical knowledge is much easier to access as well. We spoke about the job functions briefly, which are pipeline, rendering, profiling, tooling, and rigging. And the core competencies, the way I broke them down: artistic competency, technical, analytical, and collaborative. And finally, if you want to get into tech art, make sure to evaluate your skills, figure out how you're positioned, determine the best path for you to transition into tech art, and continue working on the missing skills that you have, build a portfolio, and just like you're here today, continue to meet and engage with industry professionals, build connections, participate in game jams, because all of these things can help improve your chances and help you unlock your career as a technical artist. Thank you very much.